Yeah, good evening, children. Good evening, online students.
Good evening.
Good evening.
Good evening. Yeah, so we were doing quadrilaterals, and I think we finished this one, right? If the diagonals of a parallelogram are equal, then show that it's a rectangle. So the similarity between a parallelogram and a rectangle is that in both opposite sides are equal. In a parallelogram and in a rectangle, opposite sides are equal. In a parallelogram, diagonals are unequal. If the diagonals of a parallelogram are equal, then it is a rectangle. It is a parallelogram because we know a rectangle is a special parallelogram. It is a parallelogram, so a further special name is a rectangle. So if the quadrilateral is identified as a parallelogram, diagonals are unequal. Okay, but in a parallelogram, if we notice that the diagonals are equal, then it's a rectangle. Okay, so this is the proof for the statement. If the diagonals of a parallelogram are equal, then show that it's a rectangle. So so what do we have to prove here? We need to use a definition of a rectangle to show that the quadrilateral is a rectangle. To show that the parallelogram is a rectangle, we need to use a definition of a rectangle. What is a rectangle? A rectangle is a parallelogram in which one angle is a right angle. Now the given figure ABCD is already a parallelogram. So we just need to prove one more, that one angle is a right angle. So we take up these two triangles. We take up the triangles ADC and BDC. BDC. That's what you see here, ADC and BDC. This triangle has the diagonal AC, and this triangle has the diagonal BD. We also choose triangle so that we can make use of the information given. We are given that AC is equal to BD. So we'll make sure that one triangle has AC, the other triangle has BD, so that we can use that information AC is equal to BD. Okay. So in these two triangles, you will see that AD is equal to BC. Opposite sides are equal. AD is equal to BC. Opposite sides are equal, right? And then this is the common side. DC is the common side. And then AC is equal to BD. Diagonal AC is equal to diagonal BD given. SS is congruence criterion. The triangles are congruent. So CPCT, you will have angle 1 is equal to angle 2. Angle 1 is equal to angle 2, CPCT. But angle 1 plus 2 is equal to 180 because they are the adjacent angles of the parallelogram. Angle 1 and angle 2 are the adjacent angles of the parallelogram. So they are supplementary. Angle 1 is equal to angle 2, but they are supplementary. So angle 1 is equal to angle 2, but angle 1 plus 2 is 180. So replace 2 with 1 or 1 with 2. So you will get twice angle 1 or twice angle 2 is equal to 180. Angle 1 is 90. So we have proved that in the parallelogram, one angle is a right angle. So it's a rectangle. In the parallelogram, we have proved that one angle is a right angle. So it's a rectangle. So this we already discussed in the last class. This one. This also we finished. No, this we didn't. No, this we didn't. Yeah. Show that the diagonals of a square are equal. Show that the diagonals of a square are equal and bisect each other at right angles. Okay. So the quadrilateral is given to be a square, and In the square, you'll have to prove three things. One, diagonals are equal. Two, diagonals bisect each other. Three, diagonals meet at right angles. The given quadrilateral is a square. You don't have to prove it's a square. It's a square. You'll have to verify the properties of the square. So given a square, show that the diagonals are equal. Show that the diagonals bisect each other. Show that the diagonals intersect at right angles. These three properties you'll have to prove. Okay. Now the second one, that the diagonals bisect each other. The second one, that the diagonals bisect each other, is already true because a square is a parallelogram. You don't have to prove this. Okay, so you can just mention this, that a square is a parallelogram, and in a parallelogram, the diagonals bisect each other. So in a square also, the diagonals will bisect each other. That's enough. A square is a parallelogram. In a parallelogram, diagonals bisect each other. That's a property of a parallelogram. In a parallelogram, diagonals bisect each other. So in a square also, the diagonals bisect each other. Now, diagonals are equal, you'll have to prove. So to show that diagonals are equal, you'll have to take one triangle that has the diagonal AC and another triangle that has the diagonal BD. To show that AC, if we call the square ABCD, to show that AC is equal to BD, you'll have to take up one triangle which has AC, another triangle which has BD. Show that these two triangles are congruent, and then CPCT you will get AC is equal to BD. You'll have to show that the diagonals are equal, right? Diagonals are equal. So you'll have to take two triangles. One should have diagonal AC, another one should have a diagonal BD. Show that they are congruent. CPCT, you will get the result. So diagonals equal, that's how you're going to prove. I'll show the proof, you can help yourself, and then maybe if needed, we'll discuss again. The second one, bisect each other, I told you. And the third one, at right angles. At right angles, for this, you should take up any two adjacent triangles like this. We have the four small triangles, no? We have the four small triangles, right? 1, 2, 3, 4. You'll have to take up 1 and 2, 2 and 3, 3 and 4, or 4 and 1. Any pair you can take. Because to show that, the diagonals meet at right angles, you'll have to prove this. This is 90 or this or this or this is 90, right? Correct. So if you take up these two triangles and show that they're congruent and say that angle 1 is equal to angle 2, then you can get that result, right? If you prove that angle 1 is equal to angle 2, but angle 1 plus 2 is 180 because it's a straight line, not adjacent angles, linear pair. Okay. This is triangle 1, triangle 2, triangle 3, triangle 4. Take up any pair of adjacent triangles, not opposite. Don't take 1 and 3, or don't take 2 and 4. Don't take up opposite triangles. Take up any pair of adjacent triangles, next to next triangles. So triangle 1, triangle 2, or 2 and 3, or 3 and 4, or 4 and 1. Any one. Okay. Now supposing you take up triangle 1 and triangle 2. Show that they are congruent. Then CPCT, you will have this angle equal to this angle. But they form a linear pair. So you will get twice of something is 180. So this angle is 90 degrees. So if you prove that this is 90, the diagonals intersect at right angles. All right. Yeah, have a look at the proof. Okay, some of us are not able to focus and, go through the slide. I can see them restless. Okay, so we'll do it together. Now, as I told you, take up two triangles that have the diagonals, these two diagonals, BD and AC. Okay, so we've taken up the triangles DAB and CBA. DAB, this triangle, and CBA, this triangle. Okay, so in these two triangles, AD is equal to BC. Why? Because ABCD is a square. Now, in this triangle, this angle is 90. In this triangle, this angle is 90. See, when you take up this triangle, you must not see this line that comes here like this. Ignore that. See only the three sides of the triangle. Ignore anything that comes in between like this. Okay, so ignore this. When you say triangle CBA, this is triangle CBA, and this angle is 90 degrees. This one is not disturbed by this. Okay, so 90 degrees, because in a square, every corner is a right angle, and then AB is the common side, AB common side. So the triangles are congruent by SAS rule. Two sides include angle. The triangles are congruent. Now, what is important is, now we know many properties of a square. Now, to prove here, to prove these results, you can use all other properties. You know many properties of a square. You'll have to prove a few of them here, that the diagonals are equal, the diagonals bisect each other at right angles. You'll have to prove these three, right? But apart from this, a few other properties of a square. You can use all that here. You can use all those properties here in the proof. Except what you have to prove, the other properties of a square can be used in the proof. So the triangles are congruent. BD is equal to AC, CP, CT. So we prove that the diagonals are equal. Then, as we discussed, a square is a parallelogram. And in a parallelogram, diagonals bisect each other. So in a square also, diagonals bisect each other. Then, to prove that angle 1 is 90 or 2 is 90, here we have taken up these two triangles, AOB and COB. AOB, COB, these two triangles. Okay. And in this triangle and this triangle, this side is equal to this side. Because in a square, all sides are equal. This is the common side. And then AO of this triangle is equal to CO of this triangle. Because diagonals bisect each other, meaning they have the same midpoint. Both the diagonals have the same midpoint. So O is the midpoint of AC. O is the midpoint of AC, which means AO is equal to CO. Because ABCD is a parallelogram, meaning diagonals bisect each other. So SSS rule, the triangles are congruent. So CPCT, you have angle 1 is equal to angle 2. CPCT, you have angle 1 is equal to angle 2. But angle 1 plus 2 is 180. Yeah, and then the rest you understand. So like this, we prove that angle 1 is 90 degrees. It becomes suddenly twice angle 1 because angle 1 plus 2 is also angle 1 is equal to 180. So like this, we get angle 1 is 90. So we proved all the three, right? Any questions, online students? No, ma'am. Okay. This also we saw in the last class, but we'll see it again. Now here it is. Diagonal AC of a parallelogram. Diagonal AC of a parallelogram ABCD bisects angle A. So what is ABCD? Parallelogram. Diagonal AC bisects which angle? Bisects angle A. That means what? No, that means I've numbered it. That means angle 1 is equal to angle 2. That means angle 1 is equal to angle 2. It's given to you. AC bisects angle A. Angle 1 is equal to angle 2 is given to you. Or we have to show that it also bisects angle C. That is, show that 3 is equal to 4. So how do we do this? Is angle 1 equal to angle 4? Alternate angles are equal. Then angle 2 is equal to angle 3. Why? Alternate angles are equal. Then angle 1 is equal to angle 2 because given. Yeah, AC bisects angle A is given. So from this, angle 1 is equal to angle 2. That means angle 3 is equal to angle 4. 3 is equal to 4. 1 is equal to 2. So 3 is equal to 4. So 3 is equal to 4 means AC bisects angle C. If 3 is equal to 4, it means AC bisects angle C. So we proved the first subdivision. It bisects angle C also. Then prove that ABCD is a rhombus. So this again a property. In a parallelogram, if a diagonal bisects the corner angles, then it's a rhombus. The other diagonal also will bisect the corner angles. In a parallelogram, diagonal AC and diagonal BD do not bisect the corner angles. The diagonal AC in a parallelogram, diagonal AC does not bisect angle A, does not bisect angle C. Similarly, diagonal BD of parallelogram ABCD does not bisect angle B, does not bisect angle D. If even one of the diagonals of a parallelogram bisect the corner angles, then it's a rhombus. And you will see that the other diagonal also bisects the corner angles. Corner angles meaning if diagonal is BD, then B and D are the corner angles. If the diagonal is AC, then A and C are the corner angles. So now we'll have to prove that ABCD is a rhombus. So how to prove a rhombus? Use the definition. What's the definition of a rhombus? A parallelogram in which all sides are equal. A parallelogram in which all sides are equal is a rhombus. So it's already a parallelogram. You don't have to prove ABCD is a parallelogram because it's already a parallelogram. It's given it's a parallelogram. So you'll have to prove all sides are equal. But again, you don't have to prove all sides are equal because already opposite sides are equal. So it is enough if you prove. Online students, it's enough if you prove.
Adjacent sides are equal.
Adjacent sides are equal. Any one pair of adjacent sides. Any one pair of adjacent sides are equal. When opposite sides are equal, and you have to prove that all the sides are equal. It is enough if you prove any one pair of adjacent sides are equal. All right. So this is one of the ways of doing without using. You can do using congruency also. We'll do this. Angle A is equal to angle C, right? Why? Because opposite angles are equal in a parallelogram. It's still a parallelogram. It's not a rhombus. But opposite angles are equal. Half of angle A is equal to half of angle C, right? So half of angle A is angle 1 or angle 2. Which one do you want to write? Angle 1. Okay. Then for half of angle C, which one should you write? Angle 2. Which one should you write? You want to prove that ABCD is a rhombus. Should write angle 3. You can angle 3, angle 4, both are fine, but Here, because you've written angle 1, you must write equals angle 3. Angle 1 equal to angle 4, you already know. No, all this you don't have to alternate angles are equal. So angle 1 is equal to angle 3. Now take up the triangle. Look at the triangle ADC. Look at the triangle ADC. In this triangle, angle 1 is equal to angle 3. That means it's isosceles. This side is equal to this side. So we proved that adjacent sides are equal. So in the parallelogram ABCD, AD equals DC. So now all sides are equal. So it's a rhombus. Why? Because we already have AB equal to CD, opposite sides. BC equal to AD, opposite sides equal. We already have this because it's a parallelogram. Now we have proved that AD equals DC or CD. Okay, let's just give some value. Say AB is some 5 centimeter. So CD is 5 centimeter. And here you have CD here. No, CD is 5. No, so CD here 5 centimeter. Correct? Yes or no? You watch me right or no? You can start from anywhere, children. Not that you should start from the beginning. From anywhere you can start. You can start from BC also. From anywhere, okay, like I write BC 6 centimeter. That means AD is also 6 centimeter. Where is AD now? Ah, this AD. AD 6 centimeter. That means CD is 6 centimeter. Now CD is 6 centimeter. That means AB 6 centimeter. So you can see all the sides are equal. When opposite sides are equal, and in that situation, if you're able to prove that one pair of adjacent sides are equal, that means all the sides are equal. So it's a rhombus. Okay. All right. That's exactly here. And we also discussed this yesterday. So I'll move on to the next one. This we are still to do, right? ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. So now we just finished a parallelogram. Diagonal AC bisects angle A. So we were able to prove that it also bisects C. And we proved it's a rhombus. Now this is a rectangle. In a rectangle, when the diagonals bisect the corner angles, it's a square. In a rectangle, the diagonals do not bisect the corner angles. In a rectangle, the diagonals do not bisect the corner. This is 90, no, in a rectangle. It will not be 45, 45. If it is, it's a square. Not be meaning it can be, then it's a square. If it is a rectangle and not a square, then it will not be 45. If it's a rectangle and not a square, it will not be 45. So maybe like 60, 30, whatever, 70, 20, whatever. But it will not be 45, 45. So in a rectangle, if the diagonal bisects the corner angles, if the diagonal AC bisects angle A and angle C, then it's a square. That's what we'll have to prove. Prove that it's a square and also prove that diagonal BD bisects angle B as well as angle D. Yeah. So this is similar to that of a rhombus. I'll show you the presentation. Have a look and then we'll discuss. Yeah, please go through online students and then we'll discuss. All right. Now the figure should all okay, I'll change this one. It should look like a square because you're going to prove that ABCD is a square, right? Okay, so I should change this one. It should not, because this one is a rectangle. This one is not a square. Correct? You understand? Yeah. This one also. The figure you draw should be a square already. Only then you can say therefore ABCD is a square. So don't make it look like a rectangle only. Make it look like a rectangle, which can also be called a square. Yeah. So I should also change the figures. And that doesn't affect the proof anyway. Okay. So diagonal AC bisects angle A as well as C, which means angle 1 is equal to angle 2, angle 3 is equal to angle 4. And we need to show that ABCD is a square. So what's a square? It's a parallelogram in which all sides are equal and one angle is a right angle. That's a definition of a square. A square is a parallelogram in which all the sides are equal and one angle is a right angle. So because it's already a rectangle, so it's already a parallelogram with one angle, right angle. So you just have to prove that all the sides are equal. A square is a parallelogram with all sides equal and one angle, right angle. This is the definition. It's a parallelogram and one angle, right angle we already have because it's already a rectangle. Because ABCD is already a rectangle. So we have this. So to prove that it's a square, you only have to prove all sides are equal. And to prove all sides are equal, we already have opposite sides equal. So you just have to prove that one pair of adjacent sides are equal. That's all. If in this situation, with the information given here, if you prove that any one pair of adjacent sides is equal, then ABCD is a square. So angle A is equal to angle C, right? So half of angle A is equal to half of angle C. So half of angle A is angle 1 and half of angle C is angle 3. So angle 1 is equal to angle 3. That means this side is equal to this side. So adjacent sides equal, which means all sides are equal. So ABCD is a square. And then BD bisects angle B as well as angle T. So you need to prove that angle 5 is equal to angle 6, angle 7 is equal to angle 8. So now it's a square. Now it's not it's a rectangle, but further it's a square. So to prove that, see, you'll have to prove that 5 of this triangle is equal to 6 of this triangle. Then you'll have to prove that 7 of this triangle is equal to 8 of this triangle. So if you show that these two triangles are congruent, you'll get these results. BD bisects angle B and angle D. BD bisects angle B means you'll have to prove that 5 is equal to 6. Bisects angle D, so 7 is equal to 8. So to prove that angle 5 is equal to angle 6 and 7 is equal to 8, show that these two triangles are congruent. So CPCT, you will get the results. See, when you're proving that, you just have to be a little careful. Like if you're going through congruency, now you must get the names of the triangles like this: ABD, CBD. Only then you'll get the required result through CPCT. You must get triangle ABD congruent to CBD. Otherwise, it will be a little more lengthy. So if you do this, if you prove that ABD is congruent to CBD. See, you should match vertex B and vertex D, no? Vertex B and D. They must fall in the same places. Or you should prove that ADB is congruent to CDB. These two triangles have two common points, right? B and D. A and C are different. A and C are different. B and D common. Those common vertices, they must be in the same places in both. That's all. That's all it is. So if the name of this triangle, if in congruency, if you name this triangle as say DAB, okay, then you must get congruent to D means D only you should get. A, C, B is B. Am I clear? So use this itself and write the equalities. Use this. You want to get this result. So what do you have here? DA is equal to DC. DA is equal to DC. Write that. DA is equal to DC. AB is equal to CB. AB of this triangle is equal to CB of this triangle. Then DB is equal to DB common set. Then you will get this name. Then triangle DAB is congruent to DCB. So angle D is equal to angle D. Angle D of this triangle is equal to angle D of this triangle. Angle B of this triangle is equal to angle B of this triangle. See, though the letters are the same, the angles are different, no? Angles are different. In this triangle, this is angle D. In this triangle, this is angle D. In the square, this is angle D. For this triangle, this one is angle B. For this triangle, this is angle B. Okay, so you want to get this result ABD congruent to CBD. Okay, ABD, CBD. So write these. AB is equal to CB. So you should write in triangle ABD and triangle CBD. 1. AB is equal to CB. AB of the first triangle is equal to CB of the second triangle because it's a square, all sides are equal. Then BD is equal to BD common side. BD is equal to BD common side. Then AD is equal to CD. AD is equal to CD. AD is of one triangle, CD is of the other triangle. AD is equal to CD. Because it's a square, all sides are equal. Then you will get these, meaning this order. Therefore, triangle ABD congruent to triangle CBD, SSS, CPCT, this angle B. That is, when we say angle B, it is angle ABD is congruent to or equal to angle CBD. And then angle ADB is equal to angle CDB. In the first triangle, in this triangle, angle B is equal to angle B of this triangle. That is, angle ABD is equal to angle CBD. Then this angle is equal to this angle. That is angle ADB. Put that letter in the middle, that's all. Is equal to angle CDB. So you can see BB, DD, they fall in the same places. That means you will get angle 5 is equal to angle 6, 7 is equal to 8, CPCT. So this means BD by 6, angle B and angle D. 5 is equal to 6, that means BD by 6 angle B. 7 is equal to 8, which means BD by 6 angle D. Can we go to the next one, children?
Yes, ma'am.
Okay. So here ABCD is a parallelogram. ABCD is a parallelogram. 2 points P and Q are taken on the diagonal BD such that DP equals BQ. DP equals BQ. Show that APD, this triangle, is congruent to CQB, this one. Yeah. I want it from you. Online students, offline. Think and tell me, how do you show that these two triangles are congruent? ABD, CQD. See, one of the, easiest ways is, even if you can't think, see, you can check like this. Is AP equal to CQ? Ask yourself, is AP equal to CQ? Can we write AP equal to CQ, children? No. How? No. We have not still proved that they're congruent. I'm like saying sometimes if, see, this is a simple one, but I'm just telling you from the name itself, you can get the information. You're only going to write pairs of equal sides or angles, right? You can get the order, meaning you can get the relevant ones from here itself from the name, but you must check if it is given or if you can give a reason for that. You cannot simply write AP equal to CQ. Check if AP equal to CQ. Can you write AP equal to CQ? No, you can't. Can you write PD is equal to QB? PD equal to QB? Yeah. So that is one information. PD equal to QB because that's given. PD is equal to QB. Then can you write AD equals CB? Why? Yeah, you can write that. You can write that because AD is equal to CB because opposite sides of parallelogram are equal. Now you have two pairs of equal sides, no? Fix one angle, that's all. You should bring the included angle. It has to be the included angle. There's no choice. So you know now which is the angle included between PD and AD? PD. PD and AD. PD and AD. Which is the included angle? This one only. And which is the angle included between the sides QB and CB? QB. And CB. See this one, CB. This angle. Now, see here, does it make a Z? Are the angles in the Z? Then they are alternate angles. Why? Because this is parallel to this. So sometimes, like when you have to prove that two triangles are congruent, the order is given there. Prove that this triangle congruent to this triangle, the order is already there. From that itself, you can start thinking in the exam, like. You understand? Okay. So that's all it is. This angle is equal to this angle because alternate angles are equal. These two lines are parallel. This is the transversal. Alternate angles are equal. So these triangles are congruent. And CPCT will get AP equal to CQ. AP equal to CQ, CPCT. Because we proved that these two triangles are congruent, right? So from this, it follows that AP equal to CQ. AP equal to CQ, you cannot write, children. AP equal to CQ, no. You can't give a reason for that. Then can you write PD equal to QB? Yes. PD equal to QB given. Then AD. AD equal to CB. AD equal to CB. Why AD equals CB? AD equals CB. Because ABCD is a parallelogram. Opposite sides are equal. So you can write this. Okay, you should give that reason. So now we have two pairs of equal sides. It is not SSS. It is not SSS. So it has to be SAS. So then it has to be the included angle. So which are the sides? In the first triangle, it is PD and AD. In the first triangle, PD and AD. This is PD. This is PD. This is AD. So this is the included angle. In the second triangle, it is QB and CB. QB and CB. So it is this angle in the second triangle. And yes, these two angles are equal because they're alternate angles. They alternate angles. The alternate angles made by the transversal BD with the lines, with the parallel lines AD and BC. Alternate angles are equal. So SAS congruence criterion, the triangle congruent, CPCT, AP equal to CQ. In the same way, you can do you can proceed in the similar way for the third one, AQB. AQB and CPD. Is AQ equal to CP? AQCP? Online students, can we write AQ equals CP?
No, ma'am.
No, we cannot. Okay, then can we write QB equals PD? QB
Yes.
equals
Yes,
PD?
ma'am.
QB equals PD? Yes, we can write QB PD because it's given. QB equals PD, it's given. So we can write this. Then what's the other one? ABCD. AB equal to CD? Yes. Why? Opposite sides of parallelogram ABCD. So AB equals CD. Now find it has to be SAS. So which is the angle between these two sides? QB and AB. QB, QB and AB. AB. This angle. And the angle between PD and CD. PD. PD and CD. That is DC, this one. This angle. You have to show those angles are equal. There's no choice. You have to show these two angles are equal. So you have to give some reason. So line, transversal line. So it's like this parallel line, transversal, parallel line. Here and here are the angles. Alternate interior angles are equal. AB is parallel to CD. BD is the transversal. Alternate interior angles are equal. So that means SAS rule, the triangle is congruent. So CPCT, you will get AQ is equal to CP. All right. Now after this, the last one, APCQ is a parallelogram. APCQ is a parallelogram. We have proved that AP is equal to CQ. AP is equal to CQ. And we have proved that AQ is equal to CP. AQ is equal to CP. So in the quadrilateral APCQ, both the pairs of both the pairs of opposite sides are equal. This is also one of the criteria to show that a quadrilateral is a parallelogram. In the quadrilateral APCQ, both the pairs of opposite sides are equal. You have not proved parallel, not needed. They're equal. Both the pairs of opposite sides are equal. Then it has to be a parallelogram. Then it is a parallelogram. Therefore, APCQ is a parallelogram. Like I shared the images in the last class, I'll share the images. Understood this one? Online students? Any questions?
Yes, ma'am. No doubts, ma'am.
Okay. See, children, don't adopt this method always, because supposing in the exam, they ask you, they don't give you all this. They directly say, show that APCQ is a parallelogram. I'm just telling you, like, now meaning from now on, don't always look at this, the names of the two triangles and figure out from this. You should know to identify. This is just for an information. Some of you might have realized it already, but if you didn't realize and if you feel, oh my God, okay, was this also possible? Don't resort to this method. Don't resort to this method. With the information given, you should be able to look at the figure and find out, appropriate equalities to show that the triangles are congruent. This is not, I'm not guiding you to use this method. I'm not guiding you. So don't do that. What if directly they ask you to show that AP is equal to CQ, AQ is equal to CP, and then show that this is a parallelogram? You don't have these at all. Then what will we do? Yeah. So to show that AP is equal to CQ, you'll have to take up this triangle which has AP, this triangle which has CQ, and you have to find out the equalities. No. Yeah. Then we'll be stranded. Similarly, if these are not given, prove that AQ is equal to CP. So you should take up this triangle which has AQ. Sorry, you must take up this triangle which has AQ. Then you should take up this triangle which has CP, this triangle which has CP, and show that they are congruent. So then in that case, you should be able to figure out the information, right, to suit a congruence rule. Yeah. ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on the diagonal BD. Okay. Show that triangle APB, this triangle, this big one, APB is congruent to CQD, this one. That means take away this triangle, this one, this APB, this one, and not this triangle, this one. To show that these two triangles are congruent to each other. Yeah. Yeah. Tell me. It is a simple one. ABCD is a parallelogram. Tell me, children. Yeah, next. Angle P is equal to, correct? Correct. Yeah, darling. So louder. AP is equal to CQ. Sorry? No, BD is not a side of any triangle, no. BD is not a side of any triangle. PQ also. PQ is a part of the sides. Check. See, how do you make out that? Right, and check the sides of the triangle. APB. Which are the sides? AP, PB, and AB. So PQ is not a side of any triangle. Just a second. 1 second. Yeah.
And we can use AAS rule to prove that these two triangles are congruent.
Yeah, you can use. Yes. Information. Yes, Swati, go ahead.
Angle CDB is equal to angle DBA as their alternate interior angle.
Okay. Okay, then
Ma'am,
tell
and
me
then
all the three.
yes, ma'am, and then APB is equal to angle CQD as it's given as they are 90 degrees, and then AB equals CD as the opposite sides of a parallelogram, and so by AAS, triangle APB is equal congruent to triangle CQD.
Correct. Correct, Swati. Good. Yeah. So this angle of this triangle is equal to this angle of this triangle because they're alternate angles. Alternate angles. Parallel line, transversal, parallel line. Alternate angles are equal. See, this is one triangle. The other triangle is this is the other triangle. So in this triangle, this side is equal to in this triangle, this side, because opposite sides of parallelogram ABCD are equal. Then this angle, let's call it angle 1. This angle of this triangle is equal to this angle, we'll call it 2. Angle 1 of the first triangle is equal to angle 2 of the second triangle. Alternate interior angles are equal. And you can see that this one is an angle of this triangle. Angle 3 is an angle of this triangle. Angle 4, this one, angle 4 is an angle of this triangle. angle 3 is equal to angle 4, 90 degrees given. So it is two angles and some other side. Tell me the included side, 1 minute. 1 minute. So I said angle 1 is equal to angle 2, 3 is equal to 4. Yeah. In triangle APB, which is the included side for angle 1 and angle 3? Which is the included side? For angle 1 and angle 3, which is the included side?
PB, ma'am.
Yeah. Like, you're only. No, ma, which is the included side? PQ. நீங்க அந்த triangle side full-ஆவே சொல்லல. PQ is not a side of the triangle at all. Okay, where is angle 1 formed? At which vertex? At which vertex is angle 1 formed? B. At which vertex is angle 3 formed? Put it together. That's all. That's only the included side. And Swati was right. Angle 1 is formed at B and angle 3 is formed at P. No, BP is the included side. And in triangle CQD, we have mentioned about angle 2, and I'm not saying angle 1 is equal to angle 3. We're using the two angles of the triangle to find the included side. Not angle 1 equal to angle 3. And in the second triangle CQD, we have mentioned about angle 2 and angle 4. So which is the side included by these two angles? Angle. Side? D? Yeah, DQ. Where is angle 2 formed? At D. And where is angle 4 formed? At Q. DQ is included side. But do we have BP equal to DQ? No. If you have to say that the triangles are congruent by ASA, that is two angles on the included side, these are the included sides. If you have to say that the triangles are sorry, if you have to say that the triangles are congruent by okay, by ASA, then you must have this information, BP is equal to DQ. But no, BP may be equal to DQ, but now we don't know that, right? Yeah. So it is not ASA, it is AAS because it is two sides and some other two angles and some other side. Which is that some other side? AB equal to CD. Am I clear, children? In the first triangle, for angle 1 and angle 3, BP is the included side. In the second triangle, for angle 2 and angle 4, DQ is the included side. If you have this information, BP, the included side of the first triangle, is equal to the included side of the second triangle, BP equal to DQ. Then it is ASA, two angles included side. But that information, BP equals DQ, we don't have. But we have something else, AB equals CD. So it is two angles and some other side, not ASA. Okay, that's all. The triangles are congruent, then CPCT, AP equals CQ. All right. So it is about angle 1 equal to angle 2, alternate angles are equal. Angle 3 equal to angle 4 given. Then AB equal to CD. AAS triangle the congruent. CPCT, AP equals CQ. AP, perpendicular AP is equal to the perpendicular CQ. CPCT. That's what you have here. ABCD is a trapezium. Online children, any questions with this one?
No, ma'am. No.
Okay. ABCD is a trapezium with AB parallel to CD. So these are the properties of an isosceles trapezium. What we are proving here are the properties of an isosceles trapezium. Isosceles trapezium. Okay. The diagram is given actually. I've not put it. The diagram is given. ABCD. Trapezium ABCD. All right. All right. AB parallel to CD and AD equal to BC. So it's an isosceles trapezium. The non-parallel sides are equal. The non-parallel sides are equal. So it's an isosceles trapezium. The non-parallel sides are called the legs. They're equal. So it's an isosceles trapezium. Show that angle A equals angle B. Show that angle A equals angle B. Show that angle C equals angle D. So in an isosceles trapezium, these angles are equal. Okay, let's do this first. So for this construction, draw AE perpendicular to DC and draw BF perpendicular to DC. Simply show that these two triangles are congruent and you'll get the first two results. You'll get these two results. You'll get these two results. Show that these two triangles are congruent. After the construction, show that these two triangles are congruent. All right. Now, to show that they are congruent in this triangle and in this triangle, by construction, we have 90 here, right? By construction, 90 here, by construction, 90 here. Yeah. So right angle. Then for this triangle, AD is the hypotenuse. For this triangle, BC is the hypotenuse. They're equal. It's given. AD equals BC is given. So RH. And some other side, AE of this triangle is equal to BF of this triangle. Because AB and CD are parallel lines. And this is the perpendicular distance between the parallel lines. They will be equal. The perpendicular distance between two parallel lines is the same everywhere. The perpendicular distance between two parallel lines, AE and BF, are the perpendicular distances between the parallel lines AD and DC. So they'll be equal. So S. Right angle by construction, hypotenuse AD equal to hypotenuse BC given. And then some other side, RHS, AE equals BF. Perpendicular distance between two parallel lines is the same everywhere. So there are triangles are congruent. CPCT, you will have, you can mark this one as 1. and this one is 2. So angle 1 is equal to angle 2. Angle 1 is equal to angle 2. This is angle 1, this is angle 2. Right? Angle 1 equals angle 2. But that's not A equal to B. A is this full thing, this full thing. This full thing is B. So angle 1 is equal to angle 2 CPCT. Add 90 to both the sides. Add 90 because this one is 90, no? What is this full angle? A. Angle 1 plus 90. What is angle B? Angle 2 plus 90. And how do we know that this 90? You don't have to give the reasons, but alternate angles are equal, no? See, this is 90 means this also has to be 90. You know it is 90, but if we have to give a reason, this is 90, this is 90, so this also will be 90. Alternate angles are equal. Parallel lines. So angle A, this pole of angle A is angle 1 plus 90 and angle B is angle 2 plus 90. Angle 1 is equal to angle 2 CPCT, add 90 on both the sides. So you'll get angle 1 plus 90 is equal to angle 2 plus 90. Angle 1 plus 90 is angle A and angle 2 plus 90 is angle B. So like this, angle A is equal to angle B. C is equal to D directly you get because angle C equals angle D CPCT. CPCT. That's all. All right. Got it? Online students?
Yes, ma'am.
Okay. Others?
Yes, ma'am.
All right. Online children, use the emoji, raise your hand. Sadhna, Sabarna, Swati, Haripranav, Niveda, Mritsa, Aniruddhan, Srivatsan, Blessy, Prenu, Anugraha, and Laksha. Okay. Haripranav, you have taken 2 days more, right?
Yes, miss.
Yeah. Okay. Relaxed after the exams?
Yes, miss.
Okay, okay. All right. Yes. Third subdivision. Yeah, thank you, children. Yeah. Now, third subdivision. ABC congruent to BAD. ABC. ABC. Okay, this is ABC and BAD. BAD. So 1 minute. Make it ABC. This is ABC. BAD. Yeah. ABC, BAD. We'll have to show that these two triangles are congruent. All right. So you can see AB, AB. Both the triangles have a common side AB. You can see it from the names itself here. ABC, BAD. See here, BA, AB. They have a common side. So AB is a common side. Then AD is equal to BC is given. It's an isosceles trapezium. AD is equal to BC is given. And we just proved that angle A is equal to angle B. We just proved in the first subdivision, angle A is equal to angle B. This angle is equal to this angle we just proved. Correct? Okay. So in the two triangles, we have two pairs of equal sides and the included angles are equal. So SAS rule, the triangles are congruent. Two sides included angle, two sides included angle. This side is equal to this side, common side. Then this side is equal to this side. It's an isosceles trapezium. Given AD is equal to BC. And then angle A is equal to angle B, we proved in subdivision 1. So SAS rule, the triangles are congruent. Yeah, congruent. And then the next one, diagonal AC equals diagonal BD, CPCT. Diagonal AC, once you prove that these two triangles are congruent, AC is equal to BD, CPCT. See, how do we name the triangles correctly? I've told you how to name the triangles in the correct order. So if you call this BAD, if you call this one BAD, okay, it's given there. So maybe we'll call this BDA. If you call this BDA, then what will you call this one? AC, ACB. Correct. So once you prove that they are congruent, you can see here AC, diagonal AC is equal to diagonal BD, CPCT. Correct? So we'll just see this quickly. Again. So construction, draw AE perpendicular to CD and BF perpendicular to CD. That's a construction. Now in these two triangles, this angle is equal to this angle. Angle 1 is equal to angle 2, 90 degrees by construction. AD is equal to BC. Right angle we've got. Now hypotenuse AD is equal to hypotenuse BC given. And some side AE is equal to BF. Because the distance between two parallel lines is the same everywhere. RHS rule, the triangle congruent. CPCT, angle 1 is equal to angle 2. Add 90 to both the sides. So angle 1 plus 90 is equal to angle 2 plus 90. So we get the whole of angle A is equal to the whole of angle B. Then for C equal to D directly, angle C is equal to angle D, CPCT. Because these two triangles are congruent, CPCT, angle C is equal to angle D. Then to prove that this triangle is congruent to this triangle, this is the common side. This side equal to this side is given. And this angle equals this angle we've proved. So the triangle is congruent. And CPCT we have diagonal BD equals diagonal AC. So like this, we have seen the properties of an isosceles trapezium. These are the properties of an isosceles trapezium. All right. Yeah, do the last one in this children. The angles of ABCD of a quadrilateral ABCD. The angles ABCD of a quadrilateral ABCD are in the ratio 2:4:5:7. Try that question. Please try the sixth one.
Done, ma'am.
Yeah. So what are the angles?
40 degrees, 80 degrees, 100 degrees, and 140 degrees.
Okay. And special name?
Trapezium, ma'am.
Okay, good. That's right. You can see the other side also. 140 plus 40 is also 180. You can mention anything. 140 plus 40 is 180, or 100 plus 80 is 180. Anything you can mention. Finished? Online children? All of you?
1 second, ma'am.
Okay.
I'm unable.
Done?
Yes, ma'am.
Okay. All right. Yeah. The figure formed by joining the midpoints of the adjacent sides of a quadrilateral is a
Parallelogram.
parallelogram. Square. Square is a square itself. Quadrilateral, parallelogram. Square, square. Parallelogram,
Parallelogram.
parallelogram. Rectangle,
Rhombus, ma'am.
rhombus. Rhombus,
Rectangle, ma'am.
rectangle. The bisectors of the angles of a parallelogram enclose a. The bisectors of the angles of a parallelogram. They enclose a.
Rectangle.
No, you must say for sure. Rectangle. Is it a rectangle?
Yes, ma'am.
Yes. What about the bisectors of the, what about the bisectors of, I think we haven't still done that proof. Yeah, that will come only in circles. So I'll not ask you now. Okay. This one is a rectangle. The bisectors of the angles of a parallelogram enclose a rectangle. So all these proofs we have seen in exercise 8.2. I also shared that image with you, no? I think I shared this one. Not I think I shared this one. The quadrilateral formed by joining the midpoints of the sides of a quadrilateral is a parallelogram. See, that's what we've been proving here. In exercise 8.2, we have proved ABCD is a quadrilateral. And in the quadrilateral, we know the midpoints. PQRS are the midpoints of the sides. We have proved that PQRS is a parallelogram. ABCD is a quadrilateral. PQRS midpoints. So if you join the midpoints, the quadrilateral formed is a parallelogram. So when ABCD is a quadrilateral, PQRS is a parallelogram. Next one. When ABCD is a rhombus, the one which is got by joining the midpoints, PQRS is a rectangle. So in exercise 8.2, we have proved all these results. Not all, some of these results. This one is the first one. Rhombus, rectangle, rectangle, rhombus is proved. Yeah, only these. So the quadrilateral formed by joining the midpoints of the sides of a parallelogram is a parallelogram. Square is a square. Isosceles trapezium is a rhombus. Isosceles trapezium is a rhombus. A kite is a rectangle. For both rhombus and kite, it's a rectangle. Rhombus and kite, they're similar. Similar, no, not the same, they're similar. So rhombus and kite, both rectangle. You should remember this. Quadrilateral, parallelogram, parallelogram, parallelogram. Rhombus, rectangle, rectangle, rhombus. Square, square. Isosceles trapezium, rhombus. Kite, rectangle. In 8.1, this one. 8.1, example 5, 8.1. Show that the bisectors of the angles of a parallelogram form a rectangle. This one. The bisectors of the angles of a parallelogram, they form a rectangle. This one is a rectangle. The bisectors of the angles of a parallelogram form a rectangle. So the figure formed by joining the midpoints of the adjacent sides of a quadrilateral is a, say now, quadrilateral is a
Parallelogram.
parallelogram, square,
Square.
parallelogram.
Parallelogram.
Yeah. Third one, parallelogram, rectangle, rhombus,
Rhombus.
rectangle.
Rectangle.
Very good. And the sixth one, the bisectors of the angles of a parallelogram enclose a rectangle. Enclose a rectangle. Very good. Yeah. Yeah. Do the try 2. We'll do 3 and 4 also. We'll work the second one. We'll see the answer and then we'll try the third and the fourth. Finished?
Yes, ma'am.
Okay. Okay. If one angle of a parallelogram is 24 less than twice the smallest angle, then find the largest angle of the parallelogram. Yeah, yes, who's that? Sadhna, is it?
Swati, ma'am.
Oh, okay, Swati, yeah. Yeah, what's the measure of the largest angle, Swati?
Ma'am, 112 degrees.
112. Okay, fine. All right. Yeah, even I'll just work and we'll see if I get the same answer as you got. So children, there can only be two different angles in a parallelogram. That's the first thing you should realize. In a parallelogram, okay, there are four angles, but not four different angles. Four angles, but only two different angles because opposite angles are equal, right? So this angle is equal to this angle and this angle is equal to this angle. So now this one, by this figure, it's an obtuse angle, right? By this figure. So we'll call this one the largest angle. Angle A is the smallest angle. B is the largest angle. You can take anything as the smallest and largest, but here in this figure, A is an acute angle and B is obtuse, right? So we'll take B as the largest angle and A as the smallest angle. There are four angles, but only two different angles we have because the opposite angles are equal. So there is one small and one big angle. Only two angles are there. So smallest, largest. Now read the question. If one angle of a parallelogram is, there are only two types of angles, right? Two different angles, right? So they're talking about those two angles. So if one angle of a parallelogram is 24 less than, so basically they're talking about the adjacent angles A and B. If one angle of a parallelogram is 24 less than twice the smallest angle, then the largest angle of the parallelogram is, see here. As you read, right, okay, see here, one angle is 24 less than twice the smallest angle. That's all. This only is the largest angle. That one angle only is the largest angle. Because there are only two angles here. That one angle is only the largest angle. One angle of the parallelogram is 24 less than twice the smallest angle. So let the smallest angle be x. This is twice the smallest angle. 24 less than twice the smallest angle. Now now 24 less than twice the smallest angle is some other angle, no? And which is that angle? That's the largest angle. What other angle is there? Only these two are there in the parallelogram. That one angle, largest angle, both are the same. Because there are only two types of angles here. Two angles, two different angles. So if let the smallest angle be x, twice the smallest angle, 2x. 24 less than twice the smallest angle, 2x minus 24 is the largest angle. This is the largest angle. So the smallest angle x plus the largest angle 2x minus 24 is equal to 180. Because the adjacent angles are supplementary. The smallest angle plus the largest angle is equal to 180, right? Suddenly I forget the tables. 3, 6 are 82 remains 3, 8 are 24. So the largest angle is 2 into x. Yeah. Good, Swati. Yeah. Largest angle is 112 degrees. Huh? I made a mistake. You have made a mistake. All of you have made the same mistake. Minus from it. Finished? Yeah. In a parallelogram and in a rhombus, there can be only 2 different angles. In a trapezium, all the 4 angles can be different. In a trapezium, all 4 angles can be different. Parallelogram and rhombus, 2 different angles. Rectangle, square, all you know the angles, everything, all angles are equal. In a kite, one pair of opposite angles will be equal. The other pair is not equal. So you'll have 3 different angles in a kite. In a kite, you can have 3 different angles because one pair of opposite angles equal. Okay, then the other pair, they're not equal. So they'll be different. So you'll have 3 different angles in a kite. So in a trapezium, 4 different angles, kite, 3 different angles. In a quadrilateral and in a trapezium, 4 different angles. And in a kite, 3 different angles because one pair of opposite angles are equal. So you can have 3 different angles in a kite. In a parallelogram and rhombus, 2 different angles. Rectangle and square, all the corners are right angles. Okay, we'll only do the third one. How do you show that D is parallel to BC? Online students? DE parallel to BC. Midpoint theorem, very good. Yeah, tell me. Okay. Very good. Midpoint theorem, you're right. Yes. So in triangle ABC, how do you how do we use the midpoint theorem? In a triangle, you should know the midpoints of any 2 sides. Any 2 sides. So here you can see AD is 3 units, DB is also 3 units. That means D is the midpoint of AB. And on the other side, you can see AE is 5 units, EC is 5 units. That means E is the midpoint of AC. See, AB and AC need not have the same lengths. AB is 6 units, AC is 10 units. That is okay. But D is the midpoint of AB because AD is equal to DB 3 units. And E is the midpoint of AC because AE is equal to EC 5 units. So in triangle ABC, D is the midpoint of AB, E is the midpoint of AC. Therefore, by midpoint theorem, the line segment joining the midpoints, DE, D is a midpoint, E is a midpoint. So DE, the line segment joining the midpoints, is parallel to the third side. So DE is parallel to BC. That's enough. D is parallel to BC. So supposing D was given to you, supposing B was given to you some, say, 10 centimeters, then BC will be, if D is 10, BC is 20. Correct. What did you say? 20 you said? Then D, if D is 10, supposing D is given as 10, then BC is 20 because D is half of BC. D is half of BC. So if D is 10, BC is 20. Then find X. Next question, find X. Find angle B using angle sum property. Find angle B using angle sum property. Find angle B using angle sum property.
50 degrees, ma'am.
50 degrees. Now, since DE is parallel to BC, what will be the measure of X? Co-interior
130
angles.
degrees.
130. Co-interior angles are supplementary. Yeah. See, this is 70, this is 60. So this will be 50. Angle sum property. If this is 50, 50 50 plus X is equal to 1. 50 plus X is equal to 180 because co-interior angles are supplementary, right? D is parallel to BC. We just proved that. Co-interior angles are supplementary. So how much is angle B? How much is angle B? 50. And since D is parallel to BC, 50 plus X is equal to 180. Co-interior angles are supplementary. So X is 130. The next one, we'll just do that and wind up the session for today. The fourth one, M is the midpoint of BD. And BD bisects angle B and angle D. Give a special name to the quadrilateral ABCD. Why no response from the online students? No, yeah, of course, Swati is answering. Yes, Swati is answering. I'm like, I was referring to the rest of the class. ஆமா ஒரு பேரா சொல்லிட்டு
Parallelogram. Ma'am, parallelogram.
Okay. ABCD, you can see it is marked opposite sides are parallel, right? So it's a parallelogram. In the parallelogram, diagonal BD bisects the corner angles. So it's a rhombus, right? That only I said. You shouldn't. Children, in the figure ABCD, opposite sides are marked parallel already. So ABCD is a parallelogram. See, you are deceived by the question. Give a special name to the quadrilateral ABCD. That's why quadrilateral ABCD. It's already a parallelogram because it's marked AB parallel to CD and BC parallel to AD. It's marked in the figure. So it's already a parallelogram. In the parallelogram, the diagonal BD bisects angle B and angle D is given. Did you read this? BD bisects angle B and D. No, you didn't read. You didn't read? Yeah, that's what. So BD bisects angle B and D. So we just proved in a parallelogram, if a diagonal bisects the corner angles, it's a rhombus. Yes or no? It is a rhombus. Now tell me, find angle AMB. How much is the angle AMB? Why? Correct. 90. 90. Okay. Because it's given that M is the midpoint of, it's given that M is the midpoint of BD. M is the midpoint of BD. It's given that M is the midpoint of BD. It's a rhombus. It is a rhombus. And it's given that in the question, see, we know it's a rhombus. In the question, it's given that M is the midpoint of BD. So that means if you continue AM, it will be the diagonal AC. If you continue AM, it's a diagonal AC. And we know that the diagonals are perpendicular to each other. So angle AMB is equal to 90 degrees. The diagonals are perpendicular to each other. So angle AMB is equal to 90 degrees. Yes or no? Online students?
Yes, ma'am.
Yeah, AM. Very good. So AMB is equal to 90 degrees. All right. So I'll share all the images we have discussed today. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call. Thank you.
Thank you.
Thank you.
Thank you, children.
Thank you,
Good night.
ma'am.
Thank you, children. Good night. Thank you. Thank you, children. Good night.